We are recording this now. Hi.
You want to say hi? Okay, so now how is the working of transistor? We always put the things we want to switch on in collector circuit. Okay? Then so if IC flows mean the things we want it light up lah. Then how to make IC flows? We must make IB flows first. Okay, then we are going to learn how is the current flows in the circuit first. Okay, so now the current go out in this way. Dun, 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 dun. Okay, reach here. This point we call it as a junction. What is a junction? Junction means after this point got two or more wires that connect to resistance or anything lah, any resistor lah, alright? Now, what do you think? This current will flows to the P or flows to the Q. Like your choice, flows to the P, flows to the Q, flows to P and Q. Like P, Q, P and Q. Thank you very much. The answer is dun, dun, dun. Now go to P only. Because Q means you will have IC already. So just now what we say, if you want to have IC, you must have IB first. No IC now. So it will continue dun, 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 goes to another junction. So now this current. So now one flow here. Yes. Just one going in because no IB, so it won't go IC. The condition, if you want to have IC, you must have IB first. Okay, so now this one, when it reach here, this current will choose wants to flows where. Okay, one of the characteristic of current always wants to go an easier way. Easier way means what? Low resistance way. Okay, then now this one 1 kilo ohm. This one apa ini? This is LDR. What is LDR? Okay, for LDR, it got a very it got many characteristics. For iPhone 5 only, we always remember this BL. Yeah, don't search, don't search what is BL, no lah. BL stand for bright low. Right, jot down. Bright low. Low resistance. Bright low resistance. Okay, means when it is in the dark, means it will have what kind of resistance?
Dark high.
Yes, dark will be. No problem. Dark will be high lah, dark high. BL, you remember one enough lah. Bright low means dark high lah, right? Can, up to you. For me, my brain cannot too many. I only can remember one. So all I teach is my way lah to shorten the memory lah. Jot down already? Help me check, got BL or not? Okay, good. Alright, so now, means, let's say now is in the dark. Now is in the dark, means this resistance would be very high lah. Very high means higher than this 1k ohm. By the way, this 1k ohm, we set it in front of base. So we also call it as base resistance. So now, since this one too high, current wants to go easier way, low resistance. Yes, congratulations, you have IB now. So when you have IB, okay, because the current keep going out, so yes, now the current will flows in IC. And then they will combine in IE, and they will flow back and complete the circuit. And congratulations, now you switch on the light. Yay. Thank you, thank you, thank you. Okay, so this is the flows of current in the transistor. Okay. Yeah, you can discuss with your friend or you can ask me anything, not sure.
So teacher, even you will never go to LDR.
It will go to LDR when BL.
Oh.
Okay, so now I use a green light. Green line. Can see the green line. Now, this is in the dark lah. This is in the dark. Now, if I use a green line, so now first of all, the current will 1 minute. Okay, the current will flows out here and then reach this junction. Will the current go P or Q? Or P and Q? P only because no IB yet. So P only, then reach here. Okay, now this is in the daytime. Daytime we say bright, low. Low resistance means lower than 1K. So how? Yes, congratulations. It won't go IB. It will go straight down and come back. So, no IB, no IC lah. Then the bulb not light up lah. Okay, now can go already. Yeah. Okay, no problem. Have a seat. Bye. So now, how to describe this? Let's say we describe this for the switch on first. Okay, remember yesterday we made potential divider calculation? Okay, so when we have high resistance, means the voltage here will be high or low? Potential divider yesterday, high resistance means high voltage. By the way, the voltage here, this circuit, even though no more battery, we still call it as base circuit. So the voltage here, we call it as base voltage. Get the idea? Okay, so now let's. Okay, so the question, how the LED lights up? Okay, we use 4 point to write it on, okay? Right now, please write 4. If you don't have not enough space, maybe you write down here lah. Okay, you write down here. Right, what? How the LED lights up in the night. Hi, Dicky. You actually need to memorize 3 sentences enough. Right? Find a place. Oh, okay, good. Here also got fan. Up to you lah. Okay, number one, we must tell. Of course, we actually want IB flows and IC flows lah, but we need to look at the sensor first. The sensor here called LDR, right? We describe lah the resistance of LDR. The resistance of LDR is what in the dark. When they say night, you translate in the dark, yes. The resistance of LDR is what in the dark? Yes, it's high because BH means dark. Dark high means bright low lah. It's high in the dark. Okay? So, number 2. So, and so if you want it to light in the dark, we put at the bottom. Bottom is a base circuit. So you can see high resistance here means high base voltage. Right here, base voltage. Base voltage is high to switch the transistor. To switch on the transistor. To switch on the transistor. Yes, it's high to switch on the transistor. Switch on the transistor means now base current flows. When base current flows means there is collector current flows. Then collector current flows means LED will light up lah. But no need to repeat that because already mentioned in the question. So this is your step 5 lah. Okay, so now, then what happens if we put LDR on top? Let's see. If we put LDR on top, we say this is, let's say in the dark, high or low resistance? High resistance. So means now like the current flows to here. Go left or go down or go both? Left. Down. Both. Okay. Up. Okay. Cannot go down because no IB yet. So first of all, this is first of all. It will go straight first. Then when it reach here, can you see? This one is too high. I mean, compared to this one will be too high, then it stops here lah. Then now what happened? If we say it is bright, BL, bright low means low resistance. So, when it's low resistance, it will pass through here And obviously you can see 10K and 1K, it will go to the low resistance one. So when IB flows, now IC flows, they combine, become IE. Then the bulb lights up in the night, in the daytime. That's why we need to put LDR at the base circuit. If you want it to light it up in the night time. So far I see from SVM they only ask for nighttime only, never ask for daytime Okay? Let's draw. First of all, let's draw a transistor. Hey, go. Let's train ourselves draw the transistor. We always use NPN transistor. Then we put, let's practice draw the circuit. We always don't forget to set a resistor in the base circuit, up and down. Let's draw two resistors here. Okay. If I want to switch on the light, where should I put my light? Why you didn't draw? You draw once, you can memorize better. Right, where should we put the light bulb or light tube? This is C, this is B, this is E, where? C, yes, good. Okay. Okay, so now, how to draw LDR? LDR actually means light dependent resistor. Resistor actually means resistor lah. So light dependent, how to draw? See, we draw a box here, a transparent box, dotted line, and two arrows go in. These two arrows means it will sense the light. We will normally put on the base. Then the light shines in. Get the idea? You want to sit beside Ishan? No one here. Oh, God. Oh. Sit beside. Yeah. Okay. So now, let's recall. This is RB. This is normally R1. This is normally R2. But R2 is an LDR, so we also can say RLDR lah. LDR. Okay, then may I know this voltage, we call it as what? Yes, VB, because base voltage always at the bottom. See, actually we are just adding some part on top. We are just adding one more wire, one or two more wire. So we save one battery. Okay, VB. So how the light switch on? First of all, we say LDR is high in the dark. High in the dark means base voltage is high enough to switch on transistor. How to switch on transistor means now the current will, it's too high means the current don't want to go through LDR. Yes, it will go through base. So when there's IB, then starts to have IC. When it starts to have IC, congratulations, the light bulb lights up. This is how we set automatic lah. Okay? Right? What's your name? Muhammad? Right, Muhammad? Look at this diagram. Tell me how the LED lights up in the dark. I stand. Right? Sorry, what's your name? Huh? Haziq. Right, Haziq, how? Huh? No. I want the 4 sentences. Close your book. High. Why high? The resistance here, why high? It's in the day or night. Yeah, it's in the night because it's dark. No. That's current flow. What I say is second sentence is base voltage. Muhammad, you get some idea? So the base voltage resistance of LDR is high in the dark. So base voltage, yeah, it's high to switch on the transistor. So now then, what current flow? You cannot just say current flow. Huh? Base current flow. So when base current flows, collector current flows, so LED light up. Okay, thank you very much. Hakim, repeat. Hakim, repeat. Next would be you all. Louder, please. It's high. Why it's high? Yeah, it's in the dark. So, yeah, base voltage also high. It can be switched on. Yeah. Yes. Yes, so LED lights up because LED always put around collector current. Thank you. Okay, Aswani, you ready? Okay, I ask, what's your name? Sorry. Huh? Lina, okay, how? High in the dark. Increases. Switch on transistor. Base current flows. Collector current flows. Yes, good. Right, beside Ryan, what's your name again? Ching Ching. Right, Ching Ching, how? The resistance of LDR is high. Base voltage is high. And it's on the resistor Yeah, very good. That's it. Okay, good. If you can memorize these four already, then it will be easy for you for next. Next.
I see is resistance of IR is low in the
Base of the
resistance of IR is low in the
can. As long as you describe BL or DH, up to you lah. Yes. So base voltage is, if like this, base voltage is low, it will go down and come back. So it won't go in base, won't switch on.
Oh, so base voltage is low, so trans is not.
Yeah.
So LED doesn't like.
Yes. Because no IB, no IC. Yeah. So low means lower than this, the current come back lah. So no light lor. You must switch the current in B. Then only C flows, then only this light up. So you set a condition now. What condition you want it? You want to have IB. Depends on your sensor. LDR actually is sensor. All of the sensor inside is we change the resistance. Photo. Now you go there. You feel your friend not good enough. You feel you are too scared of me, so you go away. Get. By the way, if you are interested on it, you can go search that. There are a lot of sensors. This we form 5 we just learn 2 lah, light sensor and thermistor. Thermistor means temperature sensor. And we got smoke sensor, we got gas sensor, we got color sensor, alcohol sensor, rain sensor. And in China, I saw many of them put this to the windows. So they put this sensor so that the windows can close automatically when rain. Yeah, I feel I want to try. Can Luna? Eh? Okay. Okay. Bye. I'm not sure. Okay. Then we got water flow sensor. For example, my mom always forgot to close the tap. So I bought water flow sensor for her lah. Huh? No, it will ring on the handphone. Yeah, so my mom, okay, go fast, go. It's connected to handphone now. So it will show some message. The water is overflow now. Touch sensor. Many lah, but we just learned these 2 lah. Okay, now let's see what is a thermistor. Okay, thermistor. We always put on top, LDR at the bottom, thermistor put on top. How to draw a thermistor? It is a resistor with a line like this, Therm means heat. So actually this is temperature sensor. Temperature sensor. So like remember this is hot load. HL. Just now is bright low, now is hot low. So means cold is high. Like let's see, cold. Cold is high resistance. Let's see. Cold means normal lah. Normal temperature now. Room temperature now lah. So go. So now the can see the current goes through here. You may find out. Why here got two lines? You don't care this one first. Okay, the C is over here. What happened in the first of beginning? The current will go. Yeah, will go left. Continue. And then when it reach here, cold temperature is too high. So the current cannot pass through. So nothing happened. But, oh no. But, oh no. When it's fire time, it will be hot. Hot means low temperature. So, gung, 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 gung. Okay, so now low resistance means the current pass through here and it will reach a junction. This one please change to 10k ohm. They fixed already. This one fixed already, 10k. So now current characteristic is what? Go where? Wait. Okay, so now 1 and 10. The current will go which way? Mohammed? The current will choose to go which way? 1k or 10k ohm? 10. Sure, 10k. 10k, then I need to extend your time to go to toilet. Why? Because resistance is something makes your life hard. So I stop you from going to toilet means I makes your life harder lah. So you really want to make your life harder. So you want to make your life easier means you should choose low resistance. So now the current goes in the base. So when there is IB, so the current will go down to IC. Then you will find out, these two not connected. Okay, by the way, this is called a relay switch. It will attract the relay switch to switch on, then the current also, on the same time, it also will got current pass through alarm, then the alarm ring. Yes. IC flows through here. It will switch on the relay switch. So you attract it, make it close. So now the current flows through alarm on the same time. Then it rings. Why we don't put alarm on IC? Because alarm ring normally needs bigger current. But IC normally small current. So we make another circuit here but same battery. Okay? Now, Mohammed, current will always go through low resistance or high resistance. Your life easy or hard now? What he say? He say low. Yeah, low resistance. So your life must be low resistance. So go toilet now. Okay. So, don't. You want I make it hard. Okay, like now let's write how to switch on the thermistor. Okay, like number 1, how the alarm is triggered during fire time. Right? How the alarm is triggered during fire time. Number 1. So during fire time, the thermistor is, yes, resistance of thermistor is, yeah, is low. Hot low. Alright, HL, hot low. Right low and hot low. Is low when high temperature. See how we translate, okay? Fire time means high temperature, we translate. Then now next, number 2. So means when this one, again, see when this is low resistance, means voltage up here also low lah. Up here low voltage, down here will be high voltage. So the voltage here we call the name as base voltage. Yeah, so same thing. Right, same thing. So we say base voltage is high to switch on the transistor. Okay. Number 3. That's why, right, Ashwani? So now, transistor is switched on means what current flows? Yes, base current flows. So when base current flows, right, beside Ashwani, Jiani. Yes, collector current flows. Okay, good. Now get the idea. So actually very easy to spot. By the way, page 170, right? Page 170. Page 170. These two, if you check answer, these two answer terbalik. These two answer terbalik. So, nah, like name the type of transistor T. Like Hakim? NPN, correct? Okay, you want to write NPN, you write the NPN, it's okay, don't worry. And now, the transistor circuit in the diagram is used to amplify current. State what happened to the reading of microammeter and milliammeter when like which one has larger current, micro or milli? Like, Kemi? Which one has larger current? Right? You okay? Never mind, Ishan. Seems like you sick. Yeah, milliammeter got larger current. Very good. Micro is smaller current. Okay. So, may I know the current here, we call it as IB or IC. Like, what's your name? James. Right, James? The current pass through this way, we call it as IB or IC. Sure. Yeah, IB. So the current pass through this way, we call it as IC. Congratulations. So now this is S1, this is S2. Now, the question. What happened to the reading of microammeter and milliammeter when S1 is switched on, S2 is switched off? So S1 is switched on means, well, the current flows? Actually, yes. Because now this is not potential divider, this is a complete circuit. 你们两个是在讲 physics 的东西，还是在讲其他东西啊？我感觉你们不是在讲 physics 东西嘞，啊？你生病是生病啊，也不是这样子的。再这样你就跟我分开。Okay, so now, yes, when S1 switch on, actually this is a complete circuit. Yes, so we say microammeter has what happened to the reading of microammeter? Happen, we normally say increase, decrease lah. Okay, so we say microammeter reading increases. Where milliammeter reading no change. Okay. But just now, teacher, you say got IB, then got IC. Oh. Yeah, the switch doesn't on how to let current flows, right? Unless two switch off. Okay, now what happened now? When S1 off, S2 on. So I encourage you use pencil to drop it lah. So now S2 on, but S1 off. So how? Both also no reading, right? Because no IB, so no IC. Okay, we say both ammeter no change, has no change. Okay, then now we look at challenging part 171. Read it yourself and tell me what. Oh yeah, 3 more minutes. Okay, okay, to complete the diagram. 医生你还好吗？医生啊？身体痛。OK。你要 lie down 可以 lie down。Alright, now you are required to determine a set of electronic components that is able to function in the emergency alarm. Study the electronic components suitable to each blah 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 blah. Emergency alarm lah. Highlight already?
Yeah.
You are going to design an alarm, not automatic switch. So alarm you need what? Yeah. Fast, you all choose 1 minute. You can 趴着，不要躺着可以躺。 Okay, like which one is the best? W, X, okay, Y, Z. Yeah, congratulations is X. By the way, do you know what's the difference between this and this? Yeah. By the way, this is a capacitor, and you can recall just now we never talk about capacitor. All right, so no lah. This is a normal resistor lah. Okay. What's the difference between this and this? They seem like the same, right? But actually, this is a resistance. This is a diode. Then this one, you can see the light go in, sense the light. So it's LDR, light dependent resistance. This one, the light go out. We call it as light emitted diode. Yes, this is LED. Yeah, LED actually is a diode. What's your next class? Bio. Tutorial. One more minute. Okay, so now, why you choose thermistor? By the way, how to spell thermistor, you know, right? Thermistor. Why you choose this? Yes, if you just say temperature not enough, how? So we say hot, or we say high temperature, low resistance, like that lah. Okay, it will change to low temperature. Okay, this one, this is a resistor. Why we choose a resistor? Why? Because we want to make a potential divider. Okay? We want to make a potential divider, or normally we put the thermistor up here, right? So this one hot, low resistance means low voltage. Up low voltage, down will be high voltage. This voltage we also call it as base voltage. So we want to increase the base voltage. Okay? And what is this? This is an alarm bell, is it? Why we use alarm bell? Yeah, because the sound can propagate longer distance. Imagine these lights just shine in the office. Can you see? Cannot see, right? So sound better. Why terminal S? Right? So we draw back. Why terminal S like this? So that, yeah, the current can flow through IC. So that IC can flow. Can you use the terminal and P-type, N-type connection? Cannot. Okay, so this is positive terminal, right? Positive terminal is connected to collector circuit. Okay? Or we say we make a forward. We chose this so that, yeah, it's a forward bias circuit. Okay? And I think like this, just now we learned the 4 sentences. Then you can complete your analysis SPM already. Tell your friend Please maybe write on the whiteboard today. Please do up to page 171 and then analysis SPM. How to light up we can do now already. Okay? Tell your friend. Okay, that's all. Thank you. Thank you, class. Okay, thank you, class.
There is